Good afternoon, ladies and gentlemen. I'm pleased to be here and speak with the best data center experts all over the world. I'll represent the project that I've managed for last couple of years, and for me it was a big challenge to manage project for infrastructure for new services for the biggest telecom operator in Russia. And first of all, I would like to thank Uptime Institute for their support and coverage of my back for last year, and special reverence to Julian's help, support, trust, and confidence. Few words about Russia. I know that you know about Russia very well, but I would like to add some knowledge, maybe something new for you. First, it's a very long country. Just imagine it's about 9 time zones. Flight from Moscow, it's the capital of Russia, to Petropavlovsk-Kamchatsky, it's far east, took about 11 hours. And flight from Moscow to LA, 12. It's a very long distance, and different climate zones, different people. It's not similar like in Moscow and in Far East. Big difference. Russia have got a federal structure, and we have got capitals of federal areas all over the Russia scattered. And ROSTELECOM, like the biggest telecom operator in Russia, have got represented in all federal areas. Of course, we've got a lot of people. I will show you some short information about ROSTELECOM a little bit later. But when we decided to build a network of data centers, we understood that it's impossible to build one beacon in Moscow or in Siberia, in the middle of Russia, for example, and to cover all necessary services for whole country, because it's big lands. We've got a lot of fiber channels, of course, and they're very fast. But we should build network. And it was a big challenge for me to build and design network with a dedicated network, IP MPLS, only for cloud services. For last 3 years, ROSTELECOM developed a cloud platform. And we are the operator of public services till 2015. We should provide public services all over Russia with the same level of availability, and they should be available 24/7. It was the first reason why we start talking about network of data centers. Second, we developed, during design and construction of public services portal, we understood that it should be based on the cloud platform, and we designed, and they are almost ready, about 10 services based on this cloud platform. And the last one, ROSTELECOM would like to be a key company on DC market, and we want to provide services on the world level, and we need infrastructure for new services anyway. It was a lot of challenges, and I will show you a few of them. But first one is a network of data centers for a couple of years. It's not easy, at least. Second, we should build and design main data center in Moscow, and we should design and build few data centers all over the Russia same time. I will show you in details our projects at Moscow One and federal data centers, typical design. But for federal ones, we saw a problem that was with different climate zones, different climate conditions. Climate in Moscow and in Novosibirsk, for example, highly different. And we should develop design that will be good for all of them. It's first. Second, we would like to design infrastructure based on the same equipment and same solutions for better support and to saving money, at least. For 6 sites is Moscow one and federal data centers. 5 of them will be built till the middle of next year. It's the first phase of our project. We should bought, during the 1 year, we should bought buildings for Moscow one. We should organize and buy and build connections to electricity grids. We should finish demolition works at all sites. And we should design and build network, dedicated network for connections between sites. The basic approach that was like backbone for us during the whole project was the typing and modularity. We want to build data centers that will grow step by step and will, on the one hand, we will save money. On the other hand, we will have much more flexibility and will invest money year by year depending on the sales force. But for federal data centers, they're much smaller. We've got separate modularity than for Moscow one. Few words about Rostelecom. In my understanding, maybe I'm wrong, I don't know, but Rostelecom looks like AT&T a few years ago. It's the biggest telecom operator in Russia with hundreds of thousands of employees, with 500,000 kilometers of fiber channels. And we work at all markets, traditional telecom market and the new one. We work with customers and with companies, with operators, etc., etc. And next few years, maybe couple, the main strategy of Rostelecom was to migrate from traditional operator into the universal one. We've got first positions for traditional phone services, for pay TV, for wired broadband internet access. We are in the process of construction 4th biggest mobile operator in Russia. And we've got a very well position according to United Nations rate in electronic government now. It was a big project and we made it very well. One of the most interesting projects that we finished last year and that forced accelerate requirements for the level of redundancy, level of availability of data centers was the web elections. During 8 months, Rostelecom built 94,000 points and channels to the polling stations all over the Russia. And we've got main storage of video recording that available 24/7 all over the Russia. And each and every citizen of Russia have got access to this storage and could see how election was at his polling stations. Electronic government portal. Our first cloud product that we designed and start in production 2 years ago. It was hard work because we haven't got expertise, Rostelecom traditional operator with fixed line services, and we invited a lot of smart people, each in their small area of responsibility, and we've create a very well product which works 24/7 at our sites now, and this product based on the cloud infrastructure that is distributed all over the Russia at a few sites. We've got 7,000 electronic services that already 100% electronic, and we described it about 50,000 at all that in details described at our portal. We've got 5,000 regular users on the portal, and it's really useful. We've got application at Apple Store, and it's available for Android also. It was just the first step for our cloud activities. Few of them we understood, and we saw that it will be available, it will be necessary for next few years. And electronic medicine and electronic education, etc. They are in the final stage of testing, and some of them were already in testing areas all over Russia installed last year. It's 112 is like a Russian analog of 911 call center with support for different services like medical and police, etc. We've adopted last year, and it's available now, Microsoft Office applications, and they work based on our cloud platform. We've adopted also some stock management software and Dogflow, a lot of products. Some of them work, and we've got portal07.com. It's a ROSTELECOM cloud portal, and you could check it, please. So finally, we understood that we've got a lot of applications that should work based on our data center network, and we need to build it quite fast because software guys work hard, and it looks like 24/7. And we looked at our property. ROSTELECOM have got about 30,000 buildings in property all over Russia. And after detailed search, we found some buildings, about 12, for the first stage of data center network project. It was almost the same buildings, same type of the buildings, and I was at all of them, and I've collected information about those sites, and we designed typical federal data center design, which will be good for all of them. And this design was showed to Uptime, thanks again. And they said that, okay, this design is good for tier 3, but it should be finished for some sites, and then it will be certified. I didn't say that we would like to certify all sites for the first stage. We would like to build a very redundant core network of data centers, and the second stage will be maybe with lower redundancy, but we will do the same that Christian Pilaty described yesterday. We will organize redundancy on the application level, not on the sites. Moscow 1, the biggest data center which I've designed for my career, and it probably could be the biggest one in Russia. I didn't say that 80% of all data centers in Russia are concentrated in Moscow and St. Pete. And data center market quite small. We've got probably about 100,000 square meters raised floor at all. But it's rapidly growing, like 40% year by year for the next few years. And Moscow 1 must be a representative site because we will show our new services and new face of the company. We rebranded, and you could see our ear downstairs a year ago, and our marketing guys said that this branding was very successful, maybe. I understood that it's here like 6 months later. I didn't understand. And Moscow 1 will be the main repository of personal data for Russian people, the main site for growing future services. Main NUC will be located there for data center infrastructure, for dedicated IP/MPLS network, for cloud services, for IT infrastructure, for all of that. And for 2 years, I'm looking for the site that will be good for this project. It was a big challenge for me. I know data center market in Russia very well, and I understood that it must be a site inside of Moscow Ring Road. It's first, but it should be not far from downtown of Moscow, very close to the city center, but at the same time it must be an industrial zone because we should install a lot of generators and noisy chillers, etc., etc. We need additional space around the building for security perimeter, and we should storage a lot of oil there. And it must be big because we should build a site which will grow step by step with company sales force. So finally I found what I'm looking for, and it was industrial building at old steel factory, 6 acres land size with 2 buildings. I will show you landscape plan a little bit later. And this building was 1 floor, 1 level, with 40 feet high, with very well column grids, 40 to 80 feet, and 125,000 square feet size in 1 store. And an administrative building for supporting staff close to the building and the same part of land. And now this building is using for storage of crushed cars for insurance company and storage of mineral water. I hope not for producing mineral water, just for storage. After redesign, we have got much more impressive numbers. We designed 3 additional stores there, and size of the building, total size should be about 500,000 square feet. And same size for administrative part, but it will be connected by corridor underground with the technical building, and 2 connections, direct connections to power plant for 37 meg each. This is the plan of our data center. The pink one is not very pink, but the big one on the right is the industrial building. I will show you floor plans and section a little bit later. With 2 independent inputs from utility, with parking area on the right. We've got tanks with diesel underground. It's our face of data center network. Because one of the customers, one of the core customers for Rostelecom is the Russian government and government agencies, it must be impressive and looks like very highly secured. First level of, ground level of our data center is an electrical level. And we design here generators, transformers, PDU, and UPSs, batteries with their own cooling, storage for spare parts, and storage for IT equipment that will be used for our customers. You could see that it's just a part of the building, because the right one, an office part, I didn't show that. Nobody knows what it will be there. But I know 100% that NOC should be there. Second floor is data halls, 5 lines, 3 data hall per line, and absolutely similar 192 racks each, and power consumption per rack will be about 5 kilowatt per rack on the first stage, and 7.5 kilowatt per rack on the second stage. We will add additional electricity and air handling units upstairs on the 3rd floor. On the 3rd floor, we've got air handling units. On the 4th, cooling loops and pump stations. And on the roof, we've got chillers and storage of cold water for continuous cooling. We've got small separate system downstairs between third and fourth chiller plants for special data hall, highly secured for personal data. This is the section. On the right, there is an office space where will be placed our network operations center, our security guys, some office space, meeting rooms, conference hall, etc. And we separated layer by layer engineering systems for better security and to increase speed of reaction for engineering stuff when something's wrong. Finally, we've got almost same numbers with what I'm looking for. Of course, it's not 3,000 racks, but 15 data halls for 192 each. And PE was not a main issue for us in this project, but it's not bad. It looks good for me. And certification for the design is almost finished. I hope we'll have Tier 3 certification for design in a few weeks. It's one project that we managed in Moscow, and my small team from 4 people managed during last year. Second part was federal data centers. I've traveled a lot. It was about 200,000 miles for last year around Russia, and I saw maybe 25 buildings all over Russia, and we found a few of them very well for our future construction. It's a typical PBX building that's placed in all cities and towns in Moscow, and in federal areas the same. We've got electricity there, we've got land space around for engineering systems, for generators, etc. We removed old analog telephone stations there, and instead of 2 floors, we've got 2 racks. And it's a lot of space, and nobody knows how we could use it effective. And my projects, I think, could save some of the billions for the company. We thought about greenfield project, but unfortunately, we haven't got enough time, and I couldn't check all risks with new pieces of land all over Russia. It's impossible to build anything in such size of the project for a short period of time, and if you don't know even the start point. And we decided to build data centers for our first stage at existing buildings in our property. A federal data center based on the schedule which we developed about 1.5 years ago, and one stage is 1 floor. One floor is about 180 racks with cold air and hot air containment. And engineering systems will be placed on the first floor, on the roof, and an annex building, the same part of land. Power consumption per rack will be about 5.5 kilowatt, but it's possible to install favorite cloud guys high density racks anyway and anywhere. And when we started project for this design, they said that average power consumption per rack should be about 15. I said, okay, and you will be responsible for return of investment and for sales. I said, okay, maybe 5 and 5 will be okay. Finally, we decided that we will design flexible, and we could install high-density racks there. It could be up to 3 15-kilowatt racks per hux. It consists of 2 lines of racks. And on the one hand, we should design data center for our cloud platform, and on the other hand, for public sales and for the market. And it was really hard to decide which engineering solution should be used for cooling, for example, or for electrical systems. And we saw that we've got problems with maintenance and support staff in all cities where we would like to build our data centers. And we decided to build infrastructure which well known the local market, have got representative offices for manufacturers in the cities all over Russia, and BMS, one of the main systems in this project, and we would like to control 100% of infrastructure all over Russia, and it must be available 24/7. While we didn't build second stage and we haven't got a lot of data centers and we could distribute applications and data all over Russia very easy. Finally, the biggest site will have about 5 stores and 3 data halls at all, 5 meg total power consumption by 2 lines, and N+1 engineering systems for generation and cooling, and 2N for UPSs. 1 data hall is 1 floor, and it's very easy to scale and to separate it for construction. We designed it and approved it at the federal level of technical specialists, and they said that, okay, we will support it, and we know this equipment. We understand that it will be okay for our climate, and our 5 sites for the first phase will be ready for construction in the end of May, I think. After a year of intensive work of my team, we have got very impressive results from my point of view. I like them. We've got federal design, which finished and approved by Uptime Institute. We've got Moscow 1 design, which almost finished and almost certified by Uptime Institute. We've got 5 sites which are ready for the future construction. Demolition works finished, and we've got connections to the electricity grid, to the power plants, IP/MPLS network designed, and physical lines already built, and we need just to buy and install telecom equipment for this purpose. It was very interesting that we discussed with cloud guys how we will organize network operation center, which will be one for whole network and which will support engineering infrastructure and telecommunications and IT equipment, which specialists from 451 research checked and approved. They said that it's very good design for cloud platform. And we decided that it must be one big network operation center, with maybe with separate rooms for cloud specialists and for telecom guys, because it's different departments, different people speaking at different languages, or maybe not speaking, just printing. And finally, we decided that all set. Our job was done, and then we understood that we should start construction next year. And construction and budget improvement, absolutely separate project. I hope we will finish this project with the same level of success. And thank you so much. Спасибо. I'm ready to answer to your questions.
Hi, Alexander. On your Moscow 1 data center, with the chillers, air handlers above the raised floor, was there a reason for putting them above the raised floor, and did you do anything special for containment in case you had a water leak?
For Moscow 1, yes, chillers are located at the roof, And we do not use crack units inside of the data halls. We will use, I think, a technology that looks like the same like for a Facebook data center with air handling units on the top of data halls, and it will be like cold pool inside of data halls and hot air containment with chimney, and hot air will be removed on the plenum. Lex?
Alexander, Lex Course, as you know.
Okay.
I have a question about your peak PUE.
Mm-hmm.
Because you put the federal data centers across the whole nation, is the peak PUE the worst for the worst federal, or?
Yes, for the worst conditions. We couldn't say that the worst conditions for Far East, for example, the same like for South. But on the Far East, we've got very high humidity. On the South, we've got low one. And we've checked and very accurate calculate our PUE, possible PUE. It's in just calculations for different climate zones, and we showed it to Uptime Institute also, at least for Moscow 1. And it was a lot of discussions regarding the method of calculation of PUE, which we used. But the peak PUE could be, from my point of view, it's on the level of 1.8, I think. It's not critical for us because peak PUE will be a few hours per year. It's not critical, but much more important for me, the average PUE, which will be on the level lower than 1.5, because we have got a lot of problems at some sites with electricity connections, and the dependence between IT load and engineering losses is direct. And we need, inside of same electricity, use it much more for IT load. And this was the reason why we focused on the PUE, but not strong.
Okay, thank you.
Thank you.
Thank you, Alexander.
Thank you so much.